Behind all the things we take for granted, our power grids, factories, water treatment plants, there are these hidden networks called industrial control systems. For decades, they just kind of did their thing in the shadows. But now, they're connecting to the internet, and that's made them a prime target for attackers. So we're going to break down how to secure these systems, because if they fail, well, it's not just an option, it can be an absolute catastrophe.
All right, so here's how we're going to tackle this. We've got it broken down into 4 parts. First, we'll dive right into the unique battlefield of industrial security to really get the lay of the land. Then we'll start architecting the digital fortress you need to defend it. After that, we'll put on our watchman hats and learn the art of constant vigilance. And finally, we'll go on the offensive to test our defenses, hunt for threats, and learn how to respond with absolute precision.
Okay, first things first, the fundamentals. It's really easy to think, hey, security is security, right? But securing an industrial plant, that is a whole different world from protecting a standard office network. Seriously, the challenges aren't just a little different, they operate by a completely different set of rules.
So, why is a factory so much harder to secure than an office? What's the big deal? Well, the answer isn't really about the technology itself. It's all about priorities. It boils down to this one fundamental conflict between the digital world and the physical one.
And here it is. This is the core difference, right here. In a typical IT or office environment, we protect data. Confidentiality is everything. You don't want your secrets getting out. But in an industrial plant, you're protecting the process, the physical thing that's happening. So availability is king. The system absolutely must stay running 24/7. Think about it. A data leak is bad, for sure. But a power grid going down or a chemical plant overheating, that's a public safety disaster. This one simple shift in priority changes the entire security game.
And this obsession with uptime, it creates a perfect storm for vulnerabilities. A lot of these systems are ancient, built way before anyone even thought about hacking a factory. Now, as corporate IT networks start merging with these operational or OT networks, a whole new world of threats gets unlocked. But you want to know the scariest part? An attacker doesn't even need to cause a big, flashy shutdown. They can just lie. Imagine a boiler where they fake the temperature reading. They can trick a human operator into thinking everything's perfectly fine, right up until the moment it's not.
Okay, so faced with all these unique challenges, how in the world do we even begin to build a defense? Well, you start with a blueprint. You have to architect a digital fortress, layer by layer, designed specifically to protect these incredibly critical systems.
You see, a really strong fortress isn't just one big wall. It's a whole series of defenses. The first layer is what we call segmentation. You're essentially carving up the network into these isolated vaults. So if there's a breach in one area, it doesn't compromise the entire castle. The second step is creating a heavily guarded checkpoint between the outside world and your inner sanctum. That's the Industrial Demilitarized Zone, or IDMZ. And finally, you post gatekeepers. We call them broker services that scrutinize every single thing trying to pass through that checkpoint.
All right, let's zoom in on that IDMZ for a second, because this is really important. Think of it as the ultimate security airlock. It sits right between the corporate IT network and the super-sensitive industrial floor. The key here is that nothing gets a direct connection. Every piece of data, every remote user has to pass through this single, heavily monitored checkpoint.
So, what does this actually look like in practice? Well, imagine the corporate office needs some production data. Instead of creating a risky direct link to the factory floor, that data is safely copied to a server inside the IDMZ. People can access it there without ever exposing the live systems. Or, let's say a vendor needs remote access to fix something. They don't just connect directly to your network. No way. They log into a secure jump box inside the IDMZ, which gives them this controlled, fully recorded porthole to only the specific machine they're authorized to touch. See the difference?
Okay, but let's be real. A fortress with no guards is just a pretty wall. Architecture by itself isn't enough. You need constant vigilance. See, security isn't some project you finish and then check off a list. It's a process you have to live every single day. It means having eyes and ears on your network 24/7.
Now, when it comes to monitoring, I want you to think of it as 2 totally distinct modes of gathering intelligence. On one hand, you have the passive approach. You're basically acting like a spy, silently listening to all the network chatter and reading system logs to learn secrets without ever being detected. Then, you have the active approach, where you're more like an interrogator, directly probing systems and asking them questions to see how they respond. To be really effective, you have to be both the spy and the interrogator.
So, the spy's toolkit is all about gathering that passive intelligence.
Your Security Information and Management System, or SIM, that's like the central brain, piecing together clues from logs all across the network. Your Network Intrusion Detection System, a NIDS, is basically a wiretap, listening for any malicious conversations. Host-based agents are like your inside informants, reporting directly from individual machines. And threat intelligence feeds? Those are your daily briefings, telling you who the bad guys are and what new tactics they're using.
And here's a simple rule of thumb that makes a world of difference. Your systems are constantly generating a ton of noise. The secret is learning to listen for the right signals. A really solid industry best practice is to make sure every single log with a severity level from 0, that's the most critical, all the way down to 5 gets sent to your central security brain, your SIM. This simple filter is your first and maybe your best defense against missing a critical warning.
And a hugely popular open source tool for building the security brain is what's called the ELK stack. Just think of it as a 3-part team working together. You've got Logstash, which collects all the raw data from all your sources. Then there's Elasticsearch, which is like a super fast librarian, indexing everything so it's instantly searchable. And finally, you have Kibana, the analyst who turns all that raw data into beautiful dashboards and charts that let a human being actually see what's going on.
Okay, now for the Interrogator's Toolkit. The star player here is Nmap, the legendary network mapper. It's like sending out a drone to map the entire territory, seeing what's out there. But in an industrial context, you can go even deeper. You can use specialized scripts to directly question the programmable logic controllers, the PLCs, which are the hands-on brains of the machinery, to find out exactly what software they're running. You can even use tools like Modbus CLI to literally speak the native language of these devices and check on their health.
So, your fortress is built and your guards are on watch. But you know what they say? The best defense is a good offense. You can't just sit back and wait for an attack. The final, crucial step is to get proactive, to test your own walls, to hunt for enemies that might already be inside, and to drill relentlessly for the day the alarm bells ring for real.
And this brings us to the world of threat hunting. It's actually a pretty radical idea when you think about it. You don't wait for an alarm. You start with the assumption that your automated defenses have already failed. You assume an attacker is already inside your network, moving silently. A threat hunter is the detective who actively goes looking for those faint footprints and broken twigs that the automated systems were never programmed to notice.
So how do you stress test your defenses? Well, the ultimate test is a simulated war game, a red team versus blue team exercise. The red team are your ethical hackers. They're the attackers, and they use every dirty trick in the book to try and break in. The blue team are your defenders, the internal security crew, fighting them off in real time. This is so much more than a drill. It's the closest you can possibly get to a real battle, testing your people, your processes, and your tech under live fire.
And look, when an incident inevitably happens, and it will, you can't afford to panic. The best teams follow a well-rehearsed 6-phase playbook. It all starts with preparation, long before anything goes wrong. Then it's identification of the problem, containment to stop the bleeding, and eradication to remove the threat completely. After recovery gets things back online, you get to what might be the most crucial step of all: lessons learned. This is how you turn a crisis into a stronger defense for the future.
This all raises a really critical question, right? Where can you safely practice these high-stakes skills? I mean, you can't exactly run attack drills on a live power plant. The answer is a dedicated lab. This is your safe space, a digital twin of your production environment, where your teams can learn, experiment, and yes, even fail, all without risking a single real-world system.
All right, let's bring it all together. If you remember nothing else from this, remember this. In the industrial world, availability is everything. A truly resilient defense is built in layers, starting with a solid architecture like segmentation and the IDMZ, then adding constant vigilance through both passive and active monitoring, and finally it's made battle-ready through proactive threat hunting and a well-rehearsed incident response plan.
And all of this really leads to the central, unavoidable challenge we're facing today. Every single day, these systems get smarter and more connected, all to boost efficiency. But every new connection can be a new vulnerability. So the ultimate question remains: how do we, as organizations, balance that relentless drive for efficiency with the absolute necessity of robust security? That is the tightrope we all have to walk to protect our most critical infrastructure. Thanks for joining me for this breakdown.